This is question 85 from the 2016 paper. So in this question we are given two straight lines in the Cartesian plane, one with a gradient m, the other one with p, and also y-intercepts 3 and 2, and then x-intercepts L and m. We know that the distance between L and m is 5 units, but we don't know the point's exact position, we just know the distance between them. And our task is to find the sum m plus p, that's the sum of the two gradients, given that m is greater than 1. So let's write the equations of the two lines. For the blue one, it's y-intercept at 3 and gradient m, and for the red line, intercept 2, and I haven't put anything with the gradient because they denoted it p, but because we know it has to be perpendicular to the line of gradient m, the red line's gradient has to be minus 1 over m. That's a general rule for perpendicular lines in the Cartesian plane. Now let's see what happens at y equals 0. That means on the x-axis. In other words, we'll be trying to find the x-coordinates of the points L and m. So when 0 equals mx plus 3, then x must be minus 3 over m. By the same logic from the second equation, we get plus 2m. And those are now the x-coordinates of the point m and L. But we need to be very, very careful now, because when we want to evaluate the distance between them, we need to take this coordinate with a negative sign. So it will be 2m plus 3 over m. The distance from 0 to m plus the distance from 0 to L. And although in this form it might not look like one, this is in fact a quadratic equation when we multiply by m, and we can solve it for m. And using the quadratic formula, it will be minus 5, that's 5, plus or minus 5 squared, minus 4 times 3 times 2, that's 4ac, divided by 2a, that's 2 times 2 is 4. But this was our a, b, and c. And this gives us either 3 halves for m, or m equals 1 if we take the negative sign. But since we know that m is strictly greater than 1, it cannot be 1, then it must be 3 halves, 1.5. And so the sum m plus p, which is m minus 1 over m, because that's what p is, that's now 3 halves minus 2/3, which is now 9/6 minus 4/6, which is 5/6. And that is our final answer for the sum of the two gradients, and in the exam it was option D.